Why, hello, algebra students, and welcome back to another video lesson. Today, we continue working on our multiplication of polynomials by actually working backwards and doing what's called greatest common factors, or dividing polynomials. And so we are going to continue to see if we can't move ahead in our lesson on polynomials. First question. What do you think GCF stands for? Maybe you already know. Yeah, GCF is called the greatest common factor. The greatest common factor. And remember, factors are numbers that go into. So like if I look for, let's just say the number 24, the factors of 24 are 1 with 24, 2 with 12, 3 with 8, and 4 with 6. Those are all called factors because they go into 24 evenly, so to speak. All right, and so factors. And so as we are looking for those different types of things, we're going to start to look at what's called the greatest common factor and trying to find the greatest or the largest number that goes into both 24 and 100. Take a moment and see if you can't figure out what's the greatest common factor of 24 and 100. All right, so I'm going to start with the number 24. And we've got 1 that goes with 24. And then we've got 2 and 12. Oh, I've already got them up there. Why am I going to repeat this? Silly me. All right, so we're going to leave that up there. Let's do 100. 1 with 100. 2 and 50. 3 does not go in 100. 4 goes into 100 25 times. 5 goes into 100 20 times. 6 doesn't, 7 doesn't, 8 doesn't, 9 doesn't, but 10 times 10. So if we look at the list for 100 and we look at the list of factors for 24, we're trying to find the greatest or the largest one. If we look at that list, right, I think that number that they both share in common, right, there's the common part, is 4. So the greatest common factor of both of those is going to be 4. So that's really what we're looking for when we start to talk about greatest common factor. There's a couple different methods that we can use when doing this. One, you can do it all in your head. You can think, oh, the greatest number that goes into this is this. Does it go into that? I'm not going to recommend this. It doesn't work always 100% accurately, especially when we start to throw variables. You can list all of the factors, which is what we just did on the other page. 1 with 24, 2, 12, and so on. And then you can see which one's the largest, which was 4. Or you can use what's called a prime factorization or factor tree. Okay, breaking down those numbers into their smallest prime numbers and then multiplying, figuring out what do they have in common at the end, 2 times 2. And this one's going to be a little bit more helpful when we get to the variable part. But we'll talk about that a little bit more specifically. So I want you to try, just try these 3. Pause the video right here and see if you can't find the greatest common factor for these 3. All right, I'm going to use the factor tree for this first one, just to remind you what it looks like. How do I get 28? Well, that's 7 times 4. 7 is prime, so we're just going to kind of leave it. I'll circle it for a moment. 4 can break down into 2 times 2. So those are prime. We can't break those down anymore. So we say that 28 is really 2 times 2 times 7. Those are the prime factors. Let's do the same now with 12. How do we get 12? Well, that's 4 times 3. 3 is prime. I can't break it down anymore. 4, we already discovered 4 is 2 times 2. And those are now prime. So in the end, we've got 2 times 2 times 3. So to figure out the greatest common factor, we're going to look at their last rows, right? This one and this one for 28 and 12 to see what do they have in common. And they both have a 2 times another 2. And that's it. So the greatest common factor here, we could say, was also 4. All right, well, for 90 and 30, this one might be easier to literally do in your head. What's the greatest number that goes into 30? Well, it's 30, right? 1 with 30, if I created that rainbow. Does this 30 also go into 90? It certainly does. And so the GCF here, this one might have been easier to do in your head to see that it was 30. It was the smaller of those two numbers because it definitely goes into 90. 64 and 48, well, that's a little bit trickier. And so what we might want to do is just list out all of the possibilities here. I'm going to just do one more factor tree just so we can practice it. 64 is 8 times 8. But 8 times 8 is 2 times 4. 4 is 2 times 2. This 8 is 2 times 4. That 4 is 2 times 2. So all of these 2's, there's 6 of them. So 1, 2, 3, 4, 5. So there's 6 2's. All right, let's check and see. What is 48? 2 and 24. 24 is 2 and 12. 12 is 3 and 4. But 4 is 2 times 2. So I've got 1, 2, 3, 4. So 2, 2, 2, 2 times 2 times 2 times 2 times 3 times 3. So how many 2's, right? This one's only got 2's. 2 times 2 times 2, 6 times. This one's got 2 times 2 times 2 times 2 times 3. So the most that they have in common, the greatest, is 4 of them. 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So that greatest common factor here would have been 16. So again, this greatest common factor with numbers should be reviewed based on what we've done in middle school and how you've gotten some of those factors. But the tricky part becomes, how does this tie into variables? And the best way that I can describe it is that you treat the numbers and the variables separately. And you're looking for what do they have in common. Okay, so if I break down that 10 again using a factor tree, this is 2 times 5. I can't break down 2 and I can't break down 5. So it's 2 times 5. And then the x, I'm going to break down longhand. X times x, because that's what the x squared means. All right, if I find the factor tree for 25, I get 5 times 5. Can't break down 5, and I can't break down 5, so it's 5 times 5 times x times x times x times x times x. Whew. Now what we're going to do is we're going to circle anything that they have in common, right? Anything they have in common. There's a 5, there's a 5. There's an x, there's an x. There's an x, there's an x. And that's all they have in common because this one doesn't have anything else. So I'm going to bring 5 times x down. Whatever they have in common, you bring it down and simplify into 5x squared, and that will be the greatest common factor. Okay, and so really, if you notice here, right, this one had x to the 5th and this one had x to the 2nd. When we're dealing with variables, whichever one has the least amount is actually going to be the greatest common part of the greatest common factor. And so we look to perhaps the smaller exponent and can kind of deduce that that should be part of the greatest common factor. So we're going to try a couple of these from your packet. I'm going to be on page 10 in your packet eventually. And what this is helping us to do is to eventually work backwards. What we've been doing a lot of is taking 2x times that and 2x times 2 to get the result. Well, in algebra and a lot of math, the goal is to typically solve problems, like what could x equal? And so we want to start here and go backwards to get, well, what did we multiply together to get those? And so that's kind of what we're working with. Now, on your packet today in page 10, and this is part of your practice, they're going to give you expressions, right? And then they're going to ask you to find the GCF. Right? And you might be wondering, well, what do I do if it's a plus or a minus or something like that in between? Okay. If I would have said 10x squared minus 25x to the fifth and said find the GCF, this is still the same process, right? Because there was two different terms. And so we're going to use the same process here on page 10. All right, here's number one. Find the GCF. All right, we've got two unique terms, 1 and 2. We won't worry about the subtraction sign yet. We're just worried about finding the GCF. All right, so 6, if I try and break down 6, that's 2 times 3. So those are both prime numbers, so it's 2 times 3 times 4 of the r's. 1, 2, 3, and 4. 2r squared. Well, 2 is already a prime number. R. All right, let's look at both of those and try and determine what do they have in common. Well, they both have a 2. And they both have 2 r's. 2 r's. So the GCF here would be what they have in common. 2r to the second. 2r squared. All right, try this one. See what you get for number 2. 2x squared minus 10x. Why? All right, again, some of you will notice. What's the common factor between 2 and 10? It's 2. Right? The only number that goes into 2 is 2 and 1. Okay, so it's 2. This has x and x, and this one has xy. All right, so if I multiply those and look and see what they have in common, they both only have an x. So I would say that part of the GCF is an x. We don't list the y because the first term didn't have a y. So we're not going to list that, all right? We just list what they have in common. Last one. Find the GCF of this problem, number 8. Now you'll notice this one has 3 unique terms, 3 different terms. Here's a term, oops, here's a term, and then here's a term. So we might have to do it a couple of times. Well, 3 is prime, so I don't really have to find anything with the 3. But I have 3 x's and then 2 y's. So that's the first term. 6, that's 2 times 3. 2 x's and 2 y's. And then 6 is 2 times 3. 1x and 2 y's. So now when we're finding the greatest common factor and we're looking at these, we need to make sure all 3 of them have the exact same information. All right, so not all of them have a 2. This one doesn't have a 2. This one has a 3. This one has a 3. And this one has a 3. All right, we've only got 1 x in the bottom, so I can only say that all of them have 1 x in common. They don't have any more than that. But they all have 2 y's, so I can circle both y's to say that they have that in common as well. So if we look at that, they all have a 3 times an x times a y to the squared, or to the second, y squared. And that would be our GCF. This is an essential skill for our next unit, an essential skill for us as we learn to solve and work backwards. So if you have questions about factoring and finding that greatest common factor, I urge you highly to reach out. That's it for today's video. If you got questions, again, hit me up. Otherwise, until next time, everyone, stay safe.